Hi everyone. In our previous video, we discussed that how to avoid layer 2 looping in a network when we are using the switches. So spanning tree protocol is a solution, and we discussed in details about how the spanning tree protocol actually works, and if there is a problem in the network, then how the spanning tree protocol actually converges. We discussed that. But today specifically, we are going to discuss the port roles and the port state. So we have the switch here, and we have the ports, and those ports, so these are the ports. These ports are assigned different roles, and with respect to their roles, they may be in different states. Port role actually describes port's relationship to the root switch. For example, in this case, this is our root switch. So this one is our root switch, and port role actually describes that what is the relationship of that specific port to the root switch in the network. And port role also helps in deciding the port state. So we decide that what is the role of the port, and then after deciding that, we can decide that what is the state of the port. So like forwarding or blocking. An STP, as spanning tree protocol, configures these switch ports to act in one of the following roles. So the first port role is root port. Second one is designated port, non-designated port, and this is also known as blocking port as well. And then we have the disabled port. So disabled port is somehow, it's not taking part in a spanning tree protocol, but this is somehow we are going to discuss here. So the root port. So root port are the ports which have the lowest path to the root switch. So we discussed in our previous video the lowest path cost. So any port which has the lowest path cost to the root switch, if this is the root switch, for instance, if this is the root switch, then the port which has the lowest path cost to the root switch is known as root port. And in a single broadcast domain, only one root port is allowed per switch. So for every switch, it means for every non-root switch has only one root port. So in this case, this is the root switch. This will not have any root port, but all the remaining switches in the network, they will have one and only one root port there. Then we have designated port. So all the non-root ports that are still permitted to forward traffic on the network. So of course the root port is allowed to forward the traffic. In addition to the root port, there are some of the ports which are allowed to forward traffic. Those ports are known as designated ports. And only one designated port is allowed per LAN segment. So if this is a LAN segment, then only one designated port should be there. If this is a LAN segment, then only one port should be configured as a designated port. Clear? So for every LAN segment, we will have one designated port. And designated port is selected on the basis of the designated switch we discussed in previous video. And designated switch is the switch which is going to announce the least cost to the root switch. Then we have the non-designated ports are the blocking port or the block port. So all the blocked ports are known to have non-designated role. Clear? So in this case, if this is the block port, so this is also known as non-designated port or block port. And finally, we have a disabled port, a port which has been administratively shut down. It means that will not take part in the spanning tree protocol. And what we do in that case, we go to that specific interface or the port of the switch. For example, in this case, if you want to say, for example, if you want to disable this specific port, then we go interface proxy Ethernet 0/1 and just administratively we shut it down. And once the port is in this state, we say that this is the disabled port. Clear? So now the port states. Now STP 802.1D. I'm not talking about rapid STP. I'm discussing STP only, 802.1D, and this actually defines 5 different port states. And a state tells a switch whether to send or receive the frame. So we will discuss these all states and their particular functionality in that state. Okay. So first one is the blocking state, listening state, learning state, forwarding state, and the disabled state. First one is the blocking state. In this blocking state, for example, if a port is in blocking state, for example, in this case, this is the port which is in the blocking state. If a particular port is in the blocking state, it means that port discards the data frame. It means it will not send or receive the data frame. First thing. Second thing is that port receives the BPDU and processes it. So even if the port is in blocking state, it will be receiving the BPDU or the Bridge Protocol Data Unit, and they do not learn MAC addresses. So they do not forward or receive data frames, but they are going to receive the BPDUs only, and they are not learning the MAC addresses. So these are the important functions when a particular port is in the blocking state. So this is, for example, the route which is sending a BPDU, and the port is in blocking state, but even though that port is in blocking state, it will receive that BPDU and it will process it. Next state is the listening state, and in this state, again the same thing. If the port is in the listening state, it means port will discard a data frame. It will not send as well as receive. And in this case, actually the port will start sending as well. It means it will send as well as receive the BPDU, and it will not learn the MAC addresses. The only difference is that in this case, the port is going to transmit as well as receive the BPDU. And when the port is in listening state, it remains there in that state for a time that is defined by a forward delay, and that is 15 seconds. And in learning state, if the port is in learning state, it means again the port will not send or receive the data frame still, but it will be transmitting as well as receiving the BPDU. In addition to that, it will start learning MAC addresses, or it will start populating the MAC table of the switch. And in learning state as well, the port stays in that state for 15 seconds. And finally is the forwarding state. So that once a port is in the forwarding state, it means port can transmit as well as receive data frames, and port can transmit as well as receive the BPDUs, and ports can learn the MAC addresses. It means now only in the forwarding state the port is allowed to send the data frames. They are not allowed to send the data frames in blocking state, in learning state, as well as in listening state. Only in forwarding state this is allowed to send the data frame. In disabled state, if a port is in disabled state, it means in specific that state, the ports are not allowed to send or receive data frames. They are not allowed to send or receive the BPDUs, and they are not allowed to learn MAC addresses because this is in disabled state. Okay, so these were the states of ports. Now to see this spanning tree protocol in action, let's take 3 switches. So these are 3 switches. and let's connect them together. So we need a crossover cable. So from this fast Ethernet 0/1 port to this 0/1 port, and then connect this switch with this one, and then connect this switch with this one. Okay, so we have selected 3 switches and we have connected them together. So by default, spanning tree protocol should work, and they should exchange BPDU between them, and they should decide that which switch is going to be the root switch, which of the switches are going to be non-root switches, and they should decide that which port should be in the blocking state so that there should not be any layer 2 looping. So you can see, if you can see this, the colors, so you can see these are the green colors. It means this link is active. From this switch to this switch, you can see the green color shows that this link is active. But at this point, specifically at this point, if you see, this is not green. It means this port, that is F0/2 port of this switch, that is switch 2. So this specific port has been blocked. This color shows this. Okay. So now, for example, if we go to this switch and if we see that's what's going on, then we use a command that is show spanning tree, enter, and if we maximize it, so you can see this command show spanning tree gives us information about spanning tree protocol. So this is virtual LAN, VLAN 1. And that this shows that this is the root ID. It means this is the information about the root switch. So that root switch has priority of this, and that root switch has a MAC address which is given by this. And to reach that root switch from the switch we selected, so we selected this switch. So from this switch to reach the root switch, we have to pay, or we have the cost of 19, and we use this port. So that is fast Ethernet 0/1. From this 0/1, it means this port is connected to the root switch. So it means this has been selected as a root switch, and we haven't done anything because this is automatically done with the help of spanning tree protocol. And here, in addition to that, you can see this hello time is for 2 seconds, max edge is 20 seconds, forward delay is 15 seconds, which we discussed in our previous video. And this is the priority for the root, and this is the bridge ID. So this is the information of the switch itself. So this is the information of the switch, this switch. Okay, now let's see what's going on at this root switch. If you click here, and if we again use the same command, that is, and we go to this privilege mode and then show spanning tree, enter, and here you can see this is the root switch and its priority is this, and this is the MAC address for the switch. So this says that this bridge is the root. It means now this switch is going to claim that this is the root switch, but in this case, this switch was not claiming that this is a root switch. You can see here. So in this case, this says that root switch is some other switch, but in this case, you can see this says that this bridge is the root. So this is the root bridge, and its own bridge ID, you can see they are same. You can see the MAC address of the bridge ID as well the MAC address of this root bridge, they are same. It means the same switch is acting as a root switch. In addition to that, if you look at the roles of the ports, so you can see these are the ports, our interfaces, you can see these are the ports, and they say the role of the port is designated, so designated, and this is also designated, and the state is forwarding state as well as forwarding state, and this is the cost. And this is the port priority we will discuss then later. So as the switches have the priority, in the same way the ports itself also have the priority values. So this is this is how we can see the roles, so as well as the states of the ports of the switches. Yeah. Thank you.